So let's play with a couple of things. First off, let's look at, I want to figure out if a statement is a tautology or, what's the other one, a negation, or is it always true, is it always false, or is it neither? So the first one I wanted to look at is, this is going to bleed through, isn't it? P and Q, or not P and not Q. Let's start reading this off the page. I could do a truth table. In fact, I have done a truth table. But we don't have to do a truth table. But here's a truth table. So we can see that it's not, because it's got trues and falses. Hopefully that shows up there if I put that there. But let's logic through this. Okay, let's just kind of BS through this a little bit. If they're both true, so I'm kind of doing a shortened truth table, then I know that this part will be true. P and Q is true, so the whole thing, is true. If they're both false, that means not P and not Q equals true, which means the whole thing is true. Oh, this is horrible. This must be 3 lines. So far we've got always true. Except if one's true and one's false, then P and Q is false. Not P and not Q is false. So this is an or statement. If both of them are false, the whole thing is false. So without going through the whole truth table, we can kind of look at this and go, neither. Let's look at the next one. I have to go. P and not Q, or not P and Q. Now, one thing to think about is, to look at, is this is basically the same thing that we did up here. The only difference is, instead of having Q here, we have a not Q here and a Q here. So if you replace Q with not Q, this statement is exactly the same as this statement. So the whole thing is neither true nor false all the time. Next one. How about we have P and Q, or not P or not Q. I want to play with some of my theorems here. I do not want to do a truth table. I do not like truth tables. I notice that both of these have nots in them, so I'm going to factor out the not. So we have P and Q, or, let's see how bad she's going to mess up my picture. Or if I factor this not out, I will then have a P and Q. So notice what we have here. Oh, sorry, kitty cat. If we look at the big picture, we have a statement or not that statement. So we know that P or not, R or not R is always going to be true, so this is a tautology. I don't know why they're doing this. I just fed them. They should be good. They should behave themselves. So let's see, the next one I have, see if I can fit this on the page, is not P or not Q. Oops, I should change it in the middle. Move! And P or Q. Ooh, let's factor out again. That'll help. No, it doesn't help, because if I factored out P and Q, this statement and that statement are totally different. So is it anything like the one we had up here at the very top? PN. Oh, this is connected with ors. This one's connected with ands. Damn it. Okay. So let's look at, so this is an and here. So if one of these is true, the whole thing is true. So let's say they are both true. So true here, and this is true, that's a false. So that means we have a false. If they're both false, that means I have a false here and an and, so the whole thing is false. I'm not liking this. Okay, what if one is true and one is false? Does it matter? No, they're pretty much isomorphic here. Oh, one of each. If I have one of each, well then this will be true, and this will be false, which is a true. So I have a true and a true, which makes this true. So, I went off the page for all of that. I'm so sorry. I should look up at that now and then. So I have, if they're both true, the whole thing is false. If they're both false, the whole thing is false. If I've got one of each, then it's true. So this is, again, a neither. I think I've got one more I can show you. I didn't read through too bad. She says like that. How about, pull it down so you can see it. Not P and Q and P and not Q. All of these are ands, which means these parentheses don't mean anything. I don't need parentheses. I will have, I've got a not P, and I've got a Q, and I've got a P. I know right now that because I've got P and not P, this thing's going to be false all the time. Those are some examples. I want you to do a couple of truth tables, and I want you to try some of these, figuring out if they're tautologies. More important to me is for you to read the English statements, the statements that are in English, even though they're about mathematics, and try to figure out if they're true or false. Some of this stuff is a little bit too pedantic. Anyway, so there you go. Good luck. Talk to you tomorrow or whenever. Bye.